Okay guys, let's begin the discussion over the questions. The first one is talking about area bounded by this curve where this symbol is denoting the greatest integer function. You know what does it mean, and y equals x minus 1 and x equals 0 and above the x-axis. So if I talk about this particular function, I know that x square upon 64 is greater than or equal to 0 and strictly less than 1 whenever x is lying between minus 8 and 8. That's true? Fine. This is 64, 8 square is 64, minus 8 square is also 64. I am interested in this plus 2. So x square by 64 plus 2 will be less than 1 plus 2, greater than or equal to 0 plus 2. And this is true when mod x is less than 8 or x is between minus 8 and 8. Now once you have got this, if this is greater than or equal to 2 and less than 3 for all x which belong to this particular section, I can very easily say therefore greatest integer function of x square by 64 plus 2 is 2. And therefore my function y is nothing but a constant function y equals 2. Next you have y equals x minus 1, x equals 0 and above the x-axis. So if I talk about the region to plot, it is actually y equals 2, this is the point 2, this line is y equals 2. Next you have y equals x minus 1, when you put x equals 0 you get y equals minus 1, and when you put y equals 0 you get x equals 1. This is 0 comma minus 1 and this is 1 comma 0. This is 0 comma 0. Above the x-axis and by y-axis you basically are supposed to find the area of this region. So what is this area? You know from 0 to 2 I will be interested in such a strip. Area is integral from 0 to 2 x dy. But what is x? You can see what is x? This is what? Y equals x minus 1 and therefore x is y plus 1 from 0 to 2. Clear? This becomes what? Y square by 2 plus y from 0 to 2. So you get 4 by 2 plus 2 which is 4 and that is what is your answer. That is 4 square units. Next question says what? Let's see. It is talking about the area bounded by mod of x minus 1 less than or equal to 2 and x square minus y square equals 1. Now here if you try to understand what is this trying to say basically is, if I am saying x minus 1 is less than or equal to 2, what is it that I am trying to say? All those numbers whose distance from 1 is less than 2 or equal to 2. So this is 1, this is 2, this is 3, this is 0, this is minus 1. So all the numbers whose distance from 1 is either equal to 2 or less than 2 are actually these numbers. So this implies x is greater than or equal to minus 1 and less than or equal to 3. This is the first restriction. Second is x square minus y square equals 1. This is nothing but a hyperbola. So here the area that we need to find is basically this is x equals 1, then somewhere here is x equals 3 because I need that, and then here is x equals minus 1. So my entire axis should lie from minus 1 to 3 itself. It should not go beyond it, but when I go to plot the other hyperbola, I basically obtain such a figure. Now see, if I want the area bounded by this hyperbola and the lines x equals minus 1 and x equals 3, clearly I cannot move over here. I will have to restrict myself from minus 1 to 3 itself, and therefore the area which comes into picture is this area. this area comes into picture. And so this portion of the hyperbola doesn't give any contribution because it has moved beyond -1 and my limit is still -1 itself. So this is just my area, so obviously I will be interested in such a strip, and therefore my area is going to turn out to be what? Area will be equal to integral from 1 to 3, integral from 1 to 3. What is this? This curve is x square minus y square equals 1, which is x square minus 1 is y square. So y is under root x square minus 1. This portion, but I will just be counting it till here and I will be taking actually twice of it. So twice of this above the x-axis region is actually going to give me the complete area. So I have this as my very area. Now quickly understand how are you going to move ahead with this. This is just requiring your basic formula of under root x square minus a square. If that is on your fingertips, you are going to very easily get the very answer of how many square units is actually this area constituting. So quickly try to do this, get the answer, and then we are going to continue with the discussion of the rest of the questions. Okay guys, so once we have decoded what area actually we need to find, let's just plug in the formula and get ahead with the computation of the area. This is twice of what is the integration of under root x square minus 1. I can consider this as under root x square minus a square, which is what? Integration of under root x square minus a square is 1 by 2. So 1 by 2 you can just take out common. This is going to just cancel this 2 out. You are left with x under root x square minus a square by 2. So I have already taken out 1 by 2 common. A square is 1 log of mod of x plus under root x square minus a square. That is it. And the limits are from 1 to 3. There was a 1 by 2 common, there was a 2 here, so that got cancelled out. Now you are left with 3 under root 3 square is 9, 9 minus 1 is 8, so under root 8 minus log of 3 plus root 8. Right? So this is what? This is actually 2 root 2. So your answer is 6 root 2 minus ln of 3 plus root 8 or 2 root 2. Clear? Moving to the next question, we have area bounded by fx. So fx is given to you, x-axis and x equals 0, x equals 3 by 2. What is this area? Okay, let's try to compute this now. Here if I talk about fx, you can see fx is everywhere continuous and differentiable except at x equals 2. When I talk about this very function, my interesting points are -1, and then I have 1, and then I have 2. At 2 it's not defined, right? At 2 it's not defined. Now if you can see, before -1 it's negative, here it is positive, negative, and then positive. So if that's the behavior which is being exercised by fx, I clearly can see the graph is going, and it's continuous and differentiable. So that is very important, that it is continuous and differentiable. So its graph is basically going to go something like this. From here till 1 it will be positive and then negative. The moment you've decoded this graph of f, your aim is to actually, so somewhere here is your origin. Fine. I want to talk about x equals 0, that is y-axis, x-axis, x equals 3 by 2 would be somewhere here. That's 1.5. So this is 1.5. I want to talk about this area. What will be this area? Let's see. What will be this area? You have integration from 0 to 1 fx dx. And what is this area? From 1 to 1.5 or from 1 to 3 by 2, again fx, but its negative is what I want. Because this is lying below the x-axis, is going to give me a negative quantity, so I am going to take mod of it, or I am going to take negative of it to actually get the positive area. So from 1 to 3 by 2, Here this is again fx dx. Now how you decode this? See, this is 0 to 1, fx is x minus 1, x plus 1 upon x minus 2 dx, minus 1 to 3 by 2, again x minus 1, x plus 1 upon x minus 2 dx. Okay? Here if you see, this is x square minus 1 upon x minus 2 from 0 to 1 dx, minus again the same thing, x square minus 1 upon x minus 2. Now it's pretty simple how you move to the next step. Why? Because the degree of the numerator is greater than the degree of the denominator. So when you divide x square minus 1 with x minus 2, you basically get here x square, here minus 2x. This is minus, this is plus. You get 2x minus 1. This is plus 2. So this is 2x minus 4. This is minus, this is plus. This is 3. So you basically get dividend is equals to divisor into quotient plus remainder. So you get x minus 2 into x plus 2 plus 3 whole upon x minus 2. Integral from 0 to 1. This gets cancelled out. Similarly from here 1 to 3 by 2. Then you have x minus 2, x plus 2 upon x minus 2 plus 3 again upon x minus 2 dx. So this again gets cancelled out. Now things are pretty simple. Just a linear function x plus 2. This will become x plus 2 whole square by 2. Limits from 0 to 1, this will become 3 times log of x minus 2. Limits from 0 to 1, minus this is going to become x plus 2 whole square by 2. Limits from 1 to 3 by 2, and this is going to become 3 times log of mod of x minus 2. Limits from 1 to 3 by 2. Very easily when you solve, you basically get 7 by 8 square units as your answer. Clear? Moving to the next question, let's see what is it. It is talking about the area of this region, which is consisting of all those ordered pairs x comma y such that mod x is less than equal to mod y and x square plus y square is less than equal to 1. If I talk about x square plus y square equal to 1, if I talk about x square plus y square equal to 1, it is nothing but a unit circle centered at origin with radius 1. If I'm talking about less than equal to 1, that means I'm talking about the complete interior. And when I'm talking about mod x equal to mod y, it is just x equals y and x equals minus y. So this is x equals y, y equals minus x. So interior as well as all those x comma y's for which mod x is less than equal to mod y is actually going to give you this shaded area. This is the area I need to find. What are these points? Now you should know that 1 is equal to 2 is equal to 3 is equal to 4. So I will just be computing area is 4 times area of the second region. 4 times area of the second region is going to give me this area completely, area of the shaded region. What is this point? Now, this circle is x square plus y square equals 1. In place of x, if you put y, you get y square plus y square equals 1. Twice of y square equals 1, y square is 1 by 2, so y comes out to be plus minus 1 by root 2. So this point comes out to be 1 by root 2. So y is 1 by root 2. But when y is 1 by root 2, x is also 1 by root 2. And this is going to become again 1 by root 2 comma minus 1 by root 2. I did not need this point, I just need this point because I want to talk about integration from 0 to 1 by root 2. This is 4 times integration from 0 to 1 by root 2. This minus this. That means, what is this? 1 minus x square with under root minus x dx. What is under root a square minus x square? Under root a square minus x square dx is x by 2 under root a square minus x square plus a square by 2 sin inverse x upon a plus c. So here you already have a 4. Inside it becomes x by 2 under root a square minus x square plus a square by 2 sin inverse x upon 1, then this is minus x square by 2, and this is integration from 0 to 1 by root 2. Okay? Very easily when you try to resolve this, what do you get? 2 again basically comes out common and cancels out with this, so you are just left with 2, and this becomes x, which is 1 by root 2 into 1 minus 1 by 2, which is again 1 by root 2 plus 1 by 2 times, no, not 1 by 2 because I have already extracted 1 by 2 out. Sin inverse 1 by root 2 is pi by 4 minus again 1 by 2 has been brought out, so 1 by root 2 whole square, which is 1 by 2. Fine. So this becomes 1 by 2 minus 1 by 2. Then you have twice of pi by 4, which gives you pi by 2 as the answer, and therefore pi by 2 square units is your very answer. Moving to the next question, let's see what we have. The area bounded by the curves y equals root over 5 minus x square and y equals mod of x minus 1 is what? Okay, let's see what this tries to say. It is basically saying what? Let me tell you the figure. See, if you try to decode the figure correctly, this is y square plus x square equals 5. If I square both sides, I get y square plus x square equals 5, which is nothing but a circle. But I would just be interested in plotting the upper part of the circle because I want to then talk about the area bounded by this curve and this particular mod of x minus 1. Mod of x minus 1 is y equals x minus 1 and y equals minus of x minus 1. This point is 1, 0. The target is to compute this area. Now this area can be divided into two parts, from here to here and then from here to here. What are the intersection points? Let's see. So y is these intersection points, let's see. So y is x minus 1. If I put x minus 1 whole square equals 5 minus x square, what do you get? Let's see. X square plus 1 minus 2x equals 5 minus x square. X square plus x square is 2x square minus 2x minus 4 equals 0. So you get x square minus x minus 2 is 0. X is 1 plus minus root over 1 plus 8 upon 2. So this eventually gives you what? This is 1 plus minus root 9 upon 2, which is 1 plus 3, that is 4 upon 2, that is 2, and 1 minus 3 upon 2, that is minus 2 upon 2, that is minus 1. Basically, if you talk about this, this is coming out to be 2 and, so because 1 plus 3 was 4, so this is coming out to be 2 and minus 1. This is minus 1 comma 2 and this is 2 comma 1. Why? Because when you put x equals 2, you get y equals 1. Now I am saying my required area will be what? It's very simple now. Area will be from here to here, that means from minus 1 to 1. From minus 1 to 1, it is circle minus the line. So circle is what? Root over 5 minus x square minus of x minus 1, so plus x minus 1 dx plus, then you have from 1 to 2, again circle minus this line. Circle is what? Y equals root over 5 minus x square minus x minus 1, which is minus x plus 1. Again, very easily you can compute this root over 5 minus x square by using this. And again, this is linear function, you can just compute the area, that is going to come out to be 5 pi minus 2 by 4 square units. Moving to the next one, let's see what we have. the area enclosed between the curve y equals log x plus c to the base c and the coordinate axis. Okay, so let's first try to understand what this function is going to be. Here the function is log of x plus c to the base c. Now you know when this is equal to 1, then this is equal to 0. X plus e is 1 when x is 1 minus e. So at x equals 1 minus e, this will be 0. This is somewhere 1 minus e. This is somewhere minus e. Here it is not defined. Log 0 is not defined, right? And somehow like this, the graph is going to go of log x plus e to the base e. Question is to find this area. Now it's pretty simple. It just says from 1 minus e to 0, from 1 minus e to 0, log of x plus e to the base e dx. Here again you can apply by parts. I can write it like this, x to the power 0 into this. This is the first function and this is the second. So I get first into integration of second minus integration of differentiation of the first into integration of second dx. So this is going to be from 1 minus e to 0, from 1 minus e to 0, and this is again going to be from 1 minus e to 0. Very easily when you compute this, you get 1 square units as your answer. Clear? Just apply by parts. The moment you reach at this stage, it's pretty simple integration. You will be writing x plus e minus e. X plus e upon x plus e gets cancelled. Minus e upon x plus e is what? Minus e comes out. 1 upon x plus e's integration is log of x plus e. That's it. Then apply the limits. You get 1 as the answer. Moving to the next one, we have these parabolas divide the square region bounded by the lines this and the coordinate axis. So okay, let's try to understand what this is trying to say. I know the two parabolas. It's pretty convenient to understand they are two standard parabolas. One is this, other is this. So this is y square equals 4x and this is x square equals 4y. This point is 4, 4. You can check. These two are going to intersect at 4, 4 and they are going to intersect at 0, 0. Clear? Now it is saying that y equals 4, x equals 4. This is 4 and this is 4. Right? Now this is a square. It is saying this is S1, this is S2, this is S3. S1 plus S2 plus S3 is actually this square ABCD. Okay? What is S2 plus S3? S2 plus S3 is actually this, which is from 0 to 4. What is this curve? This is y equals root 4x. Root 4 is 2. This is root x dx. Which is what? Twice of x to the power 3 by 2 into 2 by 3. This is from 0 to 4. So this becomes 4 by 3 into 4 to the power 3 by 2. Now 4 to the power 3 by 2 becomes 2 square into 3 by 2, which is 2 cube, which is 8. So this is 32 by 3 square units. That is S2 plus S3. If I just talk about S3, S3 is this. This portion again from 0 to 4. Now what is this parabola? Y is x square by 4. So this is going to become 1 by 4 x cube by 3 from 0 to 4, which is 1 by 12 into 64. Right? Which is 16 by 3 square units. Now S2 plus S3 is 32 by 3, S3 is 16 by 3, so S2 is S2 plus S3 minus S3, which is again 16 by 3, right? So S3 is 16 by 3, S2 is 16 by 3. Now you know that S1 plus S2 plus S3 is actually the area of this complete square with side length 4. So it is 4 square, which is 16. So you get S1 is 16 minus S2 plus S3, which is 32 by 3, which again comes out to be 16 by 3. So even S1 is 16 by 3. So you are getting S1 is 16 by 3, S2 is 16 by 3, S3 is also 16 by 3, and therefore S1 is to S2 is to S3 is actually 1 is to 1 is to 1. Clear? Moving to the next one, let's see what we have. Here the question is about computing the areas and then matching the figures or functions in the first column to their corresponding areas written in the second column. First is y equals x square plus 2. When x is 0, y is 2. It is somewhat like this. This is y equals x square plus 2. And you have y equals minus x. This is y equals minus x. And x equals 0 and x equals 1. Okay, so this is the area that you need to basically find. This is 1, this is 0. So from 0 to 1, it is parabola minus the line. So it is x square plus 2 minus x. So it is plus x dx. So it is x cube by 3 plus 2x plus x square by 2 from 0 to 1. 1 by 3 plus 2 plus 1 by 2. This becomes what? LCM is 6. You get 2 plus 12 plus 3, which is 17 by 6. Answer is R. So corresponding to A, you get R shaded. Let's look at the next one. What is it that we have? Y equals x square. Let's look at this now. It is y equals x square. And then it is y equals 2 upon 1 plus x square. Now see, when you talk about y equals 2 upon 1 plus x square, you know that when x is 0, y is 2. Also this graph, the values that this attains corresponding to all the x's, is never going to go beyond 2, because if y goes beyond 2, then x square is going to come out to be negative, which is wrong. So y can never go beyond 2. Moreover, you know that as x tends to infinity or minus infinity, y tends to 0. And that basically gives us this bell-shaped graph, which is 2 upon 1 plus x square, and this is y equals x square. Fine. When you talk about this area, you basically are wanting the points of intersection first of all, right? Let's just talk about this point of intersection because it is just twice of this. So this is 1, this is 2. My area is twice of 1. So if y is x square, you basically get 2 upon 1 plus x square equals x square, which is x square plus x to the power 4 minus 2 is 0. I can take x square equals t, I get t square plus t minus 2 is 0. So t comes out to be minus 1 plus minus root 9 by 2. So this becomes minus 1 plus 3 upon 2, which is 1, minus 1 minus 3 upon 2, which is minus 2. So here you basically get 1 and this is also 1. So your answer is, why? Because x square cannot be equal to minus 2, so x square has to be equal to 1 only, right? X square equals 1 means x is 1 and x is minus 1, right? Now, I am saying twice of area of 1 is actually my actual area. So this becomes 0 to 1, upper minus the lower. So this is what? 2 upon 1 plus x square minus, this is twice of 2 upon 1 plus x square minus x square dx. Twice of 0 to 1, 2 upon 1 plus x square minus x square. Now here this becomes what? 2 into, inside this is twice of tan inverse x from 0 to 1 minus x cube by 3 from 0 to 1. Clear? So this happens to be twice of 2 into pi by 4 minus 1 by 3. Right? So this becomes twice of pi by 2 minus 1 by 3, which is pi minus 2 by 3. So your answer is pi minus 2 by 3. Corresponding to B, you get Q shaded. And lastly, we have this third area. What is that? Let's see. It is talking about sin x and cos x. Graph of sin x and cos x simultaneously plotting is required in here. What is this trying to say? It is saying plot sin x. Just one cycle is enough. Then you have cos x. Now here you know this is 0, this is pi, and this is 2 pi. You know this is pi by 2, this is 3 pi by 2. Where these two intersect is actually pi by 4 and 5 pi by 4. You need to talk about this area. Okay, just one of the regions. So here you know this area is nothing but pi by 4 to 5 pi by 4. Upper one is what? What is this one? This is sin x, and the lower one is actually cos x. So you get sin x minus cos x dx. This is very, very simple, guys. Sin x integration is minus cos x is actually sin x. Plug in the values, you get 2 root 2 as your answer. Clear? Moving to the next one, we have the area bounded by the curves x equals y square and x equals 3 minus 2y square. Here if I talk about this, y square equals x is parabola with vertex 0, 0. If I talk about this, this is actually 2y square equals 3 minus x. This is again a parabola with vertex 3, 0. Okay, and this is the area you need to compute. This complete shaded region is what you need to compute. Okay, what is this? This is y square equals x, and this is x equals 3 minus 2y square. Now when you talk about the area, you basically say this is 1, this is 2. So you say area is twice of 1 plus 2. Right? Whatever is the above portion, twice of it is below. Twice of it is the complete shaded region's area. So what is 1? 1 is from, what is this? What is this point? Let's calculate. Y square is x. If you put y square equals x, you get x plus 2x. That is 3x equals 3. X is 1. So this is 1 and this is also 1. So this point is actually 1. Fine. So you get from 0 to 1, upper minus lower. So you get y is root x. Right? So I'm not taking upper minus lower because I'm just restricting myself to the x-axis. So it is what? Root x, that is it, dx, plus integral from 1 to 3. What is this curve? This curve is actually, this is not this curve, it is actually this curve. What is this? X equals 3 minus 2y square. So 2y square is 3 minus x. Y square is 3 minus x by 2. Y is under root 3 minus x by 2. So what did you do? From 0 to 1, y equals root x, plus from 1 to 3, y equals root over 3 minus x by 2. This is the area of the upper shaded region. Twice of it is going to give you the area of the complete shaded region, and that is going to come out to be the integer 4. It's very, very simple. You can just calculate this. This is x to the power 3 by 2 upon 3 by 2. Here also root 2 comes out. Again, linear function, you can evaluate this, and that comes out to be 4. So the integer associated to this is 4. Let's talk about the next one. What is it that we have? Let's see. Question says if A is the area of the figure which is bounded by the straight lines x equals 0, x equals 2 and the curve y equals 2x and y equals 2x minus x square. Okay. So let's just try to understand. So y equals 2x, let me just plot it like this. This is 1 because at x equals 0, 2 to the power 0 is 1. This is y equals 2 to the power x. If I talk about this curve, y equals 2x minus x square, I can write it alternatively as y equals minus of x square minus 2x, which is minus of x minus 1 whole square plus 1, right? Which is a parabola with vertex 1 comma 1, right? This is what? X square minus 2x plus 1 minus 1. So this is actually minus 1. Why? Because x square minus 2x, let me write it down like this, minus of x square minus 2x plus 1 minus 1. X square minus 2x plus 1 is x minus 1 whole square minus 1. Like this you can write. So it is a parabola with vertex 1 comma 1. Fine. Now you have to talk about x equals 0, x equals 2. So let me rub this. So if it goes above, I am basically interested in, this is 1. So I am interested in this area. This is y equals e to the power x. Cool. Now the moment you get this as y equals e to the power x, not e to the power x, this is 2 to the power x. The moment you get this and you have figured out what area you need to find, once you know that this is also the parabola, y equals 2x minus x square, situation becomes very, very simple to us because directly you have to integrate from 0 to 2, upper minus lower. So 2 to the power x minus this curve y is 2x minus x square. Right? When you evaluate this area, this actually comes out to be this. It comes out to be 3 by log 2 minus 4 by 3, and therefore the moment you get this area, it's pretty simple. This becomes x cubed by 3, this becomes 2x square by 2, 2 to the power x, you know 2 to the power x upon log 2. Now over here, the moment you have evaluated this, it has come out to be 3 by log 2 minus 4 by 3. Question is to evaluate the value of 3 times 3 by log 2 minus a. 3 times 3 by log 2 minus a, which is 3 times 3 by log 2 minus 3 by log 2, because this is my a, this is the area, minus of minus 4 by 3 is plus 4 by 3. 3 into 4 by 3 gives me 4. So again the integer associated with this is 4, and that completes our discussion over the questions. That's it from my side. Thank you.